Hi everybody, it's Mrs. Mancuso, and today I'm going to go through organic chemistry. So organic chemistry means that it has the element carbon in it, and the unique thing about carbon is that it has 4 valence electrons. That means it has opened up spots to form 1, 2, 3, 4 bonds. So because it can form 4 bonds, it can form chains and rings and all sorts of large molecules. So there are molecules called hydrocarbons. Hydrocarbons just have hydrogen and carbon to them. So for example, here's propane. So like propane in your grill, it has 3 carbons. Prop is the prefix for 3. So if you go here, table P gives you the prefixes. So the number of carbons are indicated this way. And carbon, you have to fill the 4 bond rule. So there's 1 bond here, so 2, 3, 4. This would be an H, H, H. And then this carbon has 2, so here would be the 3rd and the 4th bond. And this one would have 3 H's. So the name of this would be propane. So down here on table Q, they show you the homologous series of hydrocarbons. So these are the 3 types of hydrocarbons: alkanes, alkenes, and alkynes. And then the general formula for each. So this tells you how the hydrogen number compares to the carbon number. So if they're saturated, it means they have all single bonds between the carbons, and you have 2 times the number of carbons plus 2 H's. All right, so let's test it out right here. 3 C's, so double 3 is 6, plus 2 is 8. So this propane is C3H8, and then I can check 3 C's, 1, 2, 3, 4, 5, 6, 7, 8 H's. Now, if I had propene, ene tells me there's a double bond. So still 3 carbons, but a double bond here. And it doesn't matter where I put this one, because whether I put it on this or this side, it's still going to be 1 propene. There's only 1 place, because you always number from the shortest side, count from the shortest side. But now when I go around and I do my H's, this carbon already has 2 bonds, so 3, 4. And this carbon has 1, 2, 3 already, so just 4. And this carbon needs 3 H's. So this one would be 3C3H6 because it's an alkene. It has a double bond. And so 3 carbons, 1, 2, 3, 4, 5, 6. And then lastly, the alkynes. YNE tells me a triple bond. So this time I'm actually going to do a different molecule just so you see something different. So this one has 5. So that's pent. And if I put the triple bond right here, I would count from the shortest side. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So this one is 2 pent-ine. 2 tells me the location of the triple bond. The wine tells me that it has a triple bond, and pent tells me there's 5 carbons in a row. All right, and then to put the H's on it, this carbon just has 1 bond. So 2, 3, 4 bonds. This carbon already has all 4 bonds, so it does not get an H. This carbon already has all 4 bonds, so it doesn't get an H. This carbon has 2 bonds, so it gets 2 H's, and this only has 1 bond so far, so 3 H's. So if it's a pent, that means C5. If it's an ine, the formula is CnH2n minus 2. So double 5 is 10, minus 2 is 8. So I should be able to count 8 H's. 1, 2, 3, 4, 5, 6, 7, 8. All right, so those are alkanes, alkenes, alkynes. And again, the anes are the only ones that are saturated. That means they have all single carbon-carbon bonds. And these 2 were both unsaturated due to the presence of a double or a triple bond in between the carbons. Okay? All right. Now, Actually, I'm going to stop this video, and the next one I will do other classes of organic compounds.